So Kohler, we've been in power since 1920, delivering industrial power systems for emergency, prime and continuous applications worldwide. Part of the Kohler organisation, and originally the power business was created to help support power for the manufacturing in the other Kohler businesses, so the kitchen and bath segment. Obviously, in that 100+ years, we've evolved, and we've developed a dedicated data center sector, recognizing the opportunity for our products in the data center market, and seeing that as a continually growing sector, which continues to grow at over 12% a year, driven obviously by all the things that we take for granted, cloud computing, and obviously the growth of things like the Internet of Things. Yeah, we see it as being something that data center operators need reliable performance. You know, and I think, you know, with everything that we're hearing in the news, and we've seen in the US last year, over the last 12 months with power outages, and we're now starting to talk about here in Europe around security of supply, ensuring that reliability performance with backup power is even more important than it's ever been. And also, you know, the drive towards net zero and sustainable technology and reducing carbon footprints being an important part of that consideration when customers are looking to install power and backup power. You know, our sort of position is that, you know, we have the ability to provide those types of solutions globally, covering all types of requirements across the data center industry, whether that be edge computing, colo, hyperscale, and our product range now with our most recent product launches takes us up to a machine of 4 megawatts with a high-speed genset being an industry-leading product. So most of our products are designed, manufactured, tested, and inspected at our plant in Brest in France, in Finistère. The plant there is over 42,000 square meters, where we have manufacturing, warehousing, all the production facilities, test facilities, and our head offices. We've got over 740 employees on that site, and we produce machines there ranging from 7.5 to 4,500 kVA. We also have a small range, which is more of a consumer product range in the sort of the small below 7.5 kVA, which we also put through that factory as well. That factory produces in the region of about 17,000 gensets per year. And we have production line, automotive type production lines and cell-based manufacture. So we can produce things on a continual production line basis, and we can also build, from a flexibility point of view, we can build the bespoke and multiple unit large equipment in our bespoke manufacturing area. We've also got one of the biggest, in fact the biggest test facility in Europe on that site, where we can actually test gensets and test them inside acoustic enclosures as well. The ability to not just test a genset in a test cell, but also the ability to test a completely assembled genset package with all of the sound attenuation, exhaust systems, everything all assembled. We also have test laboratories there and a full training school located on that site, where we can train customers and also obviously our own employees, and also our dealer network technicians, both in hands-on technical training, but also product and sales training. So we've recently made a $6 million investment in that site to allow us to increase our manufacturing capacity and capability, and also along with that the logistics for handling the products that we're building and some of the newer stuff that we're building, and also the warehousing and storage facilities that are required to support that, really in response to what we're seeing going on in the market and our success in some of the market sectors we're in. So we've seen rapid growth over the last few years in data center opportunities for us across all of the different sectors in data centers. And whilst there was some, I'll say sort of probably delay in investment by certain customers in 2020, it was still a very strong year and still strong demand in the data center industry, and 2021 has seen that continue and continue to grow. And with where we sit currently with order backlog and orders and our pipeline, has also driven the decision to make that large investment to increase capacity. Again, like we said before, the trends we're seeing with cloud, 5G, I think, whilst it's difficult to quantify, I think, the fact that we've seen a change in how people work, and I think that will continue to have an impact going forward in terms of the need for connectivity. I think whilst we are starting to see, obviously, people returning to offices, I think, the hybrid of people working part office, part home, and the need for connectivity that people have, the use of what we're doing now with Zoom, Teams, WebEx, all of those products, have seen massive increase in traffic, and obviously that needs to be supported with the data centers that run those services. We're also seeing, in terms of what our customers are asking for, they're looking for essentially the drive for power density, always looking to be able to put more power in a smaller space. And those bigger machines, obviously, they want to do that in a way that doesn't compromise serviceability, safety, and all of the things that go with being able to package a larger machine. So, being able to package larger machines into enclosures and containers that still give them that ability to service them in the long run is important. As a manufacturer, we see manufacturing excellence as a key to our ability to deliver the right quality of product, and also to be able to continually develop that product. As I said, data centers, land is expensive, there's a limited supply. Data centers have an ever increasing power demand, with servers and computing power getting more and more power hungry in the same amount of space. So our ability to respond to that and provide the right products for those customers to drive their ability to develop and grow and increase their capacity is important. So for us, from a manufacturing point of view, continuous improvement, whether that be on the shop floor or in product development, the ability to deliver things consistently and repeatably, reduction of waste, and we're seeing these types of customers in their drive to, as people become more aware of the power required in the data center industry and how much power is consumed by data centers, their drive to be seen as not being a contributor to environmental issues, driving to net zero is flowing down their supply chain to people like ourselves. So our ability to reduce waste, our ability to demonstrate that our supply chain is reducing the impact on the environment is important, and our continual drive to make sure that our products are as clean and as environmentally friendly, both in the production and in the operation, is extremely important. And the ability to maintain those production standards. So we're in a competitive market. with a number of large global players. And we strive to be able to produce product to the highest standard. One of the key things we've done over the last sort of 10 years is we are now a genset engine manufacturer. In the past, we packaged machines from other manufacturers, but the introduction of the Kohler KD series back in 2016 was the culmination, or the sort of market launch of our own KD genset, so the Kohler diesel series. So our own machine, exclusive to us, and that allows us to be in control of the supply of the core product to cope with the demand of the data center industry. We're not relying on other manufacturers that might be supplying other people. This is our product. Obviously, as a new platform, 10 years of development on that platform, it comes to market as a very compact, high power density engine with a modular design of many of the components, which helps to improve the efficiency of servicing, reduce the number of parts that customers may need to hold or that we need to hold, and allows us to have a more streamlined approach to technician training with a range of machines that are all very similar in terms of the concept and the platforms that we use for the different power nodes. As I mentioned, we see that not only our own manufacturing, but also the procurement of components that we buy in from others is critically important. All of the equipment and the components that we have to incorporate into our product need to obviously reach the standard that we need to be able to deliver the end product to customers. So we manage our supply chain very closely, both in terms of being competitive, but also ensuring that we get the right products at the right quality and have that ability to deliver that on a global basis. And our global policies allow us to also remain competitive in that we are procuring on a global basis. We apply a constant improvement program, analysing all of our supply chain, so both the internal and external supply chains, to ensure that we continually meet those standards and identify any issues that we have and resolve those as quickly as possible. We measure that to ensure that we're meeting the required delivery and quality parameters. Part of our planning is also to make sure, obviously, that our lead times are significant, obviously, for lots of product. It's big equipment. It's not sort of thing that's always off the shelf. So ensuring that we plan into the future with global trends and issues in the market, make sure that we're able to maintain the minimum possible lead time for our customers. And in the data center industry, it tends to be, as you're probably aware, a quick moving industry. And whilst you might spend a lot of time planning, when a customer decides to give the green light and wants to go ahead, they want to move quickly. Obviously, once they secure tenants, the time between securing a tenant and occupation is critical to them. So being able to meet quick lead times is essentially one of the key things that customers are looking for. And being able to manage that supply chain minimises the risk to us, and to ensure that we're able to continually deliver those lead times demanded by our customers. Similarly, on the shop floor, we manage the shop floor activities. We have a number of processes in place for continuous improvement in the production. So really ensuring that those issues or opportunities for improvement that are identified by the shop floor are actually fed into the system, and that allows us again to make, they might be incremental improvements and they might be small, but each small improvement ultimately improves the process and allows us to ultimately deliver a better product and hopefully reduce cost, waste and lead time. Implementation of 5S, obviously originally adopted and developed by Toyota. Smart toolboxes and cabinets arranged for efficient workflow, and generally the way that the factory is designed and laid out makes things very visible, and it's a culture of trying to continually improve everything that we do. Obviously the systems we use various tools, whether it be software or feedback from the individuals on site, and we use these to visualize and optimize the operation in the factory. Automated systems, automated picking. If you go to the factory, you see lots of I would say I use the term AI, so picking, delivery of components to production lines, all done automatically from a central system, which again helps to make things efficiently, make sure that the things arrive on the production line when it needs to, and we simulate those to improve efficiency, and again reducing time that it takes to actually manufacture the product. Also use this to identify potential safety issues and constantly look at ways to reduce risk and drive towards a culture of zero accidents. All the equipment that we build, as I've mentioned before, undergoes a final testing and inspection, and the level of that's carried out will depend on the individual customer. For the production type product, there's standard production testing that's carried out at the end of the production line. But then for the larger data center type product, we'll do customer witness tests, and they can be attended by the customer. Pre-COVID, we were conducting in the region around 170 witness tests per year as physical attendances from customers. Obviously, the last couple of years has made that quite difficult, but we've actually now, last year, we actually developed and carried out a large number of witness tests remotely. So we actually are able to provide a full video witness test for people to actually see the machines being tested, and it also gives them the digital tools to have a dashboard with all of the performance parameters replicated on their virtual connection, so they can actually sit and watch in real time the test, which, to be honest, is probably not dissimilar from sitting in the control room at the test facility, other than not being physically present. So they get all of the same experience, apart from the nice dinner and the evening out in France. They do get to have all of the same technical and connection with all of the test engineers, and the ability to see everything that they've got going on in the test cell with a virtual presence. And what we have found with that as well is that you tend to find that, whereas customers might have historically sent 2 or 3 people, the witness tests that are virtual, you tend to find that you'll have people that will join those witness tests from all over the world. So whilst the site might be a UK site or a European site, you might also end up with people from the US actually joining, because they're able to do so without the need for taking a large amount of their time out of their schedule to actually travel to Europe. As I mentioned, one of the key things that we're also trying to achieve with all of our activities is a zero accident and zero harm approach to what we do, and the view that zero is possible with safety. So again, a risk-based, data-driven prevention program, and continually striving to reach a zero on-site accidents, and extending that also to the activity that we do off our own sites, but actually on customer sites as well. So critically important to maintain the same high level of prevention of risk and removal of risk for our employees and our customers when we're actually on site. Trying to identify potential areas where there may be risk of accidents and analysing how that can be improved. The zip card process to actually identify and encourage employees to flag potential issues, and an openness about reporting those to actually get those highlighted if something is identified, and resulting in ultimately a downward trend in accidents that we've actually encountered. So moving on to sort of more product based part of the presentation, we see that lots of our customers are driving a demand for customized solutions. So being in a position where we just offer product that we design and that's what we offer isn't really what those customers are looking for. They themselves are looking to try and modularize and customize their own solutions, so they have a range that they use for each individual customer, and they will have their own particular requirements and their own particular way of wanting to do things, and our ability to be flexible around how we take our core product and then optimize that for each customer and adapt that is critically important. Customers wanting to drive as much of the product into a modular form and I'm doing that, do as much of the product manufacturing off-site as possible, reducing the actual installation time on site, reducing the number of man hours spent on site. Again, it's much easier to manage production quality, it's much easier to manage cost, it's much easier to manage time, and it's much easier to manage safety if it's done in a factory environment than it is on a construction site. So the ability to build the complete system and test it off-site so that when it goes to site, it reduces the actual installation and execution time on site is something that all customers are driving and looking for. So plug and play purpose engineered systems that can be built at the factory, tested at the factory, is really where we're being asked to look at every opportunity to achieve that by our customers. And as I said, you know, this streamlining a build process, it's reducing the carbon footprint of people travelling to site, and it's lowering the cost. Our approach to this is to have essentially sort of 3 optimized solutions that we offer, which we can then adapt and make bespoke for our customers. So we've sort of divided it into sort of 3 key areas of express pods, which are generally used in the smaller data centers, up to sort of 5 megawatts. A design that we've sort of refined, and again, you know, there will be site requirements, whether it be noise or the space that's available or the configuration for air in there, out there, that sort of thing, which we can then adapt the core product. Similarly, the modular pods for regional data centers, again, we have some core sort of design principles that we work around, and we're able to modify those. And then density, which the hyperscale data centers, sort of up to the 500 megawatt sort of size. So one of the things we've done with this, and as I mentioned earlier, the drive for power density, bigger machines, And the needs and requirements of customers is we've just launched our new walk-in enclosure product, which is really around the requirements of big hyperscale data centers. And as they expand, their power requirements becoming more complex, more demanding, whether that be noise, emissions, power density. And again, the requirements that they're looking for in terms of serviceability and the product over the product's life still being key to what they want to achieve. So we've been able to now come up with the product where we're able to offer internal cooling within the enclosure itself as an option. So we can have either external or internal mounted cooling systems. We've got set mounted radiators on the genset base frame for all of our models, which obviously reduces the amount of equipment assembly on site. And it allows us to then bring the units to site in modular form with the main walk-in enclosure delivered as a unit, and then mount that on the external civil works concrete slab with all the options already connected and tested, allowing it to be a quick installation, minimal amount of site time, minimum amount of man hours on site. And these allow data center operators to use the highest power machines available without compromising on any of their requirements for the long-term serviceability, operation and maintenance of those units. So an overview of those. Obviously, one of the main constraints with this type of equipment is transportability and being able to transport it on vehicles that can achieve the maximum load heights for motorway bridges and that sort of thing. But the way we've designed this is to keep the core part of the unit to a transportable size, and then things like you see on the left of that drawing there with attenuation, air outlets, exhaust, all built as modular units that are delivered to site and then craned into position and just fitted up to the main unit. And this would be a unit that typically we would have built prior to delivery to site for the customer to witness and test. Quite often the customer will do a type test. So they'll have a number of units built and tested as a complete assembled unit, and then we would then deliver the rest of the units to site and assemble do the final assembly work on site itself. And again, the concept of the design around this was just been to take into consideration all of the various requirements that we see from our large customers of these types of units. So again, you get a number of things that are fairly standard or typical in terms of what's requested. And then again, we can adapt and have the flexibility to make those adjustments or changes that a particular customer wants, whether it be the way the air outlet is arranged, the inlet, the position of certain things. So it allows us to have a quick way of being able to engineer actually a bespoke solution, while having quite a lot of the engineering work done, the structural engineering, the design of the unit, the ability to understand noise requirements and how that will impact the unit itself, and then adjust that for each individual requirement that a customer may have on their site. As I mentioned, sound being one of the critical factors, especially when we're delivering these units into metropolitan areas, cities, and obviously, whilst they don't run very often, generally there are restrictions on noise requirements on sites, and standard options that we produce was a critical part of the design process, and it allows us, with our standard range of products, we can build at 85 dBA at 1 meter, 75, and also we also built a 65 dBA option for sites where the restriction on noise is particularly low. So a 65 dBA unit is something that we build regularly. the units are built with an M1 class fire rating, and obviously designed to work in the environments that these units tend to go into. So yeah, we supply units everywhere from the UK to the Nordics, various places in Europe. So high temperature, low temperature, snow, rain, all sorts of different environmental conditions. And again, the units have been designed to allow us to actually provide options for customers depending on what the environmental conditions might be. Similarly, to ensure the longevity of the unit and to make sure that it remains looking as good throughout its life, the quality of the actual finish and coatings on the unit, again, are designed to make sure that those units remain in good condition throughout their life. And also, you know, the ability to provide special coatings for particularly harsh environments, if it's near to a marine environment, that sort of thing, is something, again, that we're able to provide. Again, the walk-in enclosures, part of that continued investment in capability in terms of what we're able to build and responding to what we see as being the demands of the market and the demands of our customers. And the part of the investment in that $6 million investment that we've made has allowed us to expand our manufacturing capacity. And obviously, manufacturing larger and larger units requires a larger and larger capability in terms of whether that be overhead craneage, the ability to move things around within the production facility, being able to load. So it's allowed us that expansion of the shop floor capacity. We've upgraded the ability to handle and manage these units once they're built to be able to actually get them out to customers. And really, it's driven by the trends that we're seeing in the data center sector and the ability, and I think, you know, the customers' desire to see that we're actually able to do that as a manufacturer. So we actually build the units and test the units in our facility. It's not something that we just pass to a third party to do for us. As a manufacturer, we actually manufacture the complete unit. So our view is that, you know, with this and with our collaboration, whether it be with engineering companies, whether it be with end user customers, it's allowing us to really help to drive our design process and our product development in a way that actually suits what they're looking for as we go forward. You know, we don't believe that one size fits all approach is what customers want. And I think, you know, our flexibility in being able to provide some building blocks that are clearly core building blocks, whether that be the engine or the sort of the outline design of these units, is important from the early stages. But you know, we're quite flexible in being able to actually adapt that and being able to really sort of cater for the criteria of each customer and what their requirements are, whether that be their own requirements as an organization or whether it be a site requirement. And one of the things that we do is our teams work closely with customers and with engineering companies throughout the design process, right from the initial concept design, spatial planning, performance in terms of noise, emissions, whatever it might be, to actually try and develop that solution from day one, so that it actually becomes an integral part of the design process as they develop their new facilities. So just as a sort of a case study, we've recently completed a contract for a customer where we've delivered 36 gensets for a data center project in the Netherlands. And again, these were, whilst there was a core element to it, the project required a high degree of customization in terms of how the customer wanted the site to operate, how they wanted to provide resilience in the systems. So the way they wanted to be able to configure the genset with the switchgear and the ability to provide backup on the backup, as it were. And our engineering teams worked closely with the client to meet the specifications they were looking for. So essentially working with them to design a bespoke product. And then the second key part of that was then being able to manufacture, produce that and deliver it in 13 weeks. The units themselves, again, were inspected, witness tested, and signed off by the customer in our factory prior to delivery to site, and then moved from our production facility in France up to the site in Holland, where we then worked with the customer to actually deliver those units to site, do the final assembly work, and then work with the customer for all of their on-site system testing, so their ISTs, their system tests, all of their sign-offs to actually ensure that the system then worked as a complete system on the site. As we talked about earlier, environmental performance of the data center sector is becoming increasingly understood and under the spotlight, with a sort of a realization of the amount of power that's actually consumed by data centers, and customers very keen to drive improvement in a more sustainable way of providing the whole solution of the data center, and the mission critical power solutions, although it's a standby power system, is no different. It's part of their system, and they look at that as being something that they also are driving towards a more sustainable and less environmentally impacted part of their operations. Obviously, regulations continue to become stricter, and the need and desire to reduce emissions across the operations is driving that. So something that we need to consider and do consider and continually work towards is the environmental performance of our product and how we improve that, and a number of ways that we work on that. So we have, again, an ongoing research and development program, working on clean technologies across all of our sectors, whether that be data centers or any of the other products that we do. And whilst there's no silver bullet, for want of a better term, in terms of being able to suddenly come up with the solution to all of these issues, we do take an approach that whatever we do, those incremental approaches to improving the products that we offer and reducing the impact all add up. So design changes on the product, better efficiency, optimizing the performance, exhaust gas after treatment to reduce emissions, whether that be CO, NOx, particulates, all of those are things that we continually look to improve and reduce the impact of our product. And part of that ongoing program, we fit after treatment and technologies to reduce our emissions on the machines that we deliver. One of the other areas that we're working on in Kohler is the renewable technologies, and what happens in not only this year, next year, 5 years, 10 years, and further ahead. Research and development into fuel cells, hydrogen fuel cells, utility scale batteries. And there's a number of programs that we have where we're working on all sorts of technologies, some of which we are bringing to market currently, where we have hybrid systems and battery systems in the sort of domestic size and moving into the industrial sizes, and work that we're doing with partners on fuel cell technology and the next technologies that go beyond where we are today. But I think, one of the things that's where we're at the moment, it's a balance between what's available, what's reliable, what's commercially viable. So continuing to work with our current platforms and improve those and reduce those is something that's sort of today's problem. And one of the things that we've done is now our entire range is tested and certified for running on HVO, which again is something that customers have been pushing and looking for. So it allows us to still provide the reliability. It allows us to still provide the products that we provide today in terms of the robustness of the diesel engine, but it allows us to use fuels that are reducing the net emissions from that product when it actually comes into service. And something that allows us to offer those options to customers. And part of our roadmap, as I mentioned, allows us to introduce new technologies into various different markets, whether that be fuel cells, batteries, or alternative fuels. And a number of things that we've got already coming to market are the fuel cells for residential, the battery packs for residentials, obviously at the smaller end of the market, and working on fuel cells for industrials, which would be able to replace some of our diesel range, and the battery packs, which again, specific to certain sectors, given the technology as it is today, which is obviously a rapidly moving and improving technology. But our roadmap allows us to actually plan out how we actually tackle some of the challenges that we all face, and being able to bring new products to market that actually move us forward in terms of that development of new technologies. So I think that gives you a quick overview of sort of what we're doing and where we are.
Yeah, just on the sustainability, net zero. I mean, we're all acutely aware of what's going on, both nationally, globally, COP26 and all that. Do you have any thoughts as to where the data center industry, I guess there's two sides, there's the supply side and obviously then the data center operators. Any thoughts as to sort of where those people, those two groups are and where they need, I mean, everyone talks about net zero, so clearly it's a great ambition, but is it a bit pie in the sky? As you alluded to in your presentation, we need to be a bit more sort of realistic as to what is achievable over what kind of time frame.
I think the desire is there and the will is there. I think if you look at the data center industry, and I sort of touched on it when I talked about supply chain, there are data center operators, customers out there that clearly want to be at net zero or improve what they do. I think that there are things that are being done today. There are data center operators out there that plant millions of trees to offset what they see as being their footprint. There are those that are buying green energy. But I think the fact remains at the moment that there's a sort of a balance between that sort of ability to be able to have the 5 nines reliability. And I think generally the grid and the network that most of these operators are connected to is actually reasonably reliable. So we're not talking about running diesel gensets for hundreds and hundreds of hours a year. I mean, they're more of an insurance policy than they are actually a power generation site. And things like HVO help us to move that game incrementally forward because it's better than running on distillate fuels. So I think, the desire is there. I don't think that there is like I said, I think it's a balance between being able to achieve a minimum impact, but doing it in a way that's both robust and reliable and also cost effective. And there are examples of data center companies out there that are doing trials on fuel cells, but the technology is still not where it needs to be able to replace the technology that we currently have today. So I think there's a sort of a dual path, really. There's a where we need to get to and a roadmap over the next sort of 2 years, 5 years, 10 years of what can be done today. And then there's a vision of where we need to get to, and also the investment in those technologies, so that I think part of it is about a partnership with those organizations, whether it be the way that the infrastructure in the data center is designed, whether it be how we apply that technology. I think is a mix at this stage. I don't think there's any quick fix to where we currently are. So I don't think that I think the diesel engine will be around for a while yet. We talk to customers about gas, but essentially we're still, when we move to gas, you could argue, well, it's not really any different. It's just a different form of fossil fuel. So I think in the short term, there's a sort of a real push to understand what's possible. But I think everyone appreciates the fact that that's probably a few years down the line before we're actually in a situation where those technologies are reliable enough and the scale that will allow them to actually deploy them in large hyperscale type data centers.
You said obviously that well, thankfully the gensets aren't required to to operate for that long period of time, but the current scenario we're all aware of, again, with the crisis that I suspect some people have seen coming and others seems to have taken totally by surprise, the volatility in power prices and therefore supply as well. Do you think that before things get better in terms of alternative fuel sources kicking in, there may well be a bit more volatility? I'm hoping the data center industry will be one of the last people to be denied power, because obviously it's pretty critical to most aspects of life. But do you think the data center industry needs to be prepared for a bit more supply volatility, and therefore the backup generators are going to be under scrutiny a bit more, or do you think it's literally
I think that's I think that's a distinct possibility. I mean, I think at the end of the day, if you look at the demand and you look at the amount of things that we're looking to actually use electricity for, and the current issues that we have around supply, there's an inevitable that there will be probably more of a volatile network out there in certain parts of the world. So yes, I mean, you would have to say that the likelihood of relying on a standby power solution is probably going to increase in the short term. And clearly in the short term, we don't have a solution for next year. So you're probably correct in that backup power will come under more scrutiny, and I think that's why for us, being able to move towards things like HVO, the ability to install sites with exhaust after treatment to really clean the emissions from the machines when they do operate is critically important. And it's probably we're probably further forward in terms of the technology that we can apply than what's actually currently being demanded. There's a lot of sites that we build where we have made provision and design systems to accept after treatment and fit, whether it be SCRs or other pieces of kit to those gensets at a future date if that is requested. So I can foresee where there are sites that have been built that will ultimately end up being upgraded to reduce the emissions if there is more demand on those pieces of equipment. I think that local authorities have probably taken a view in the past that the network is stable, and the argument has always been it's a standby facility, it'll only run for a certain number of hours a year, so the impact is minimal. I think if we see an increase in the number of hours that standby equipment is called upon due to instability on the network, then I think that those regulations and local authorities will start to impose greater restrictions on what's acceptable from an exhaust point of view. I mean, London being a good example, if you go to certain parts of London, there are large, enormous numbers of diesel gensets, whether they be ours or anybody else's. So an instability in the grid or a network outage in those parts of metropolitan areas would have an impact, because you're going to have a lot of equipment starting. And some of those have been built for 10, 15, 20 years. So they don't actually have the same level of technology or the same level of emissions treatment as what's possible today. So I think, it will come under more scrutiny, and I think that there will be a requirement to fit the best available technology, which may not have been expected in the past.
And just on the actual fuel side of things, I know, I've certainly read and heard about potential issues. If diesel is stored for months and months without actually getting used, there are potential problems when it is suddenly required to fire up a gen. A, do you get involved in helping people, educate people on that? And B, these alternative energy sources, do they have their own sort of storage and then usage issues, or are they easier to fire up from sitting idle for months on end? Just any thoughts on that?
I think certainly in terms of fuel storage is something that we do a lot of work on. So a lot of our customers, we install fuel management systems. So we'll actually install fuel polishing systems which remove bacteria, remove sediment, that type of thing from the fuel, so that you don't end up with hundreds of thousands of litres of fuel being wasted that can't be used. One of the two biggest reasons for diesel gensets not starting is batteries being flat because they haven't been tested, or fuel being less than optimum, shall we say, and filter blockages, that sort of thing. So and I think over the years, customers have realised and have understood those issues. With storing large amounts of fuel for long periods of time. So it's fairly standard. Part of our solution is to actually provide filtration and polishing equipment to actually maintain fuel quality. In terms of other technologies, yes, there are issues with certain technologies. Diesel engines are very good when you start the machine. You start the machine and seconds later you've got power available and you can run the site. It's not quite as rapid for some other technologies in terms of time between an outage and the ability to actually provide full power. So again, it's a technology that when you look at it, it's the diesel technology we apply today. It ticks a lot of boxes in terms of what customers are looking for. And again, we see sites where even when sites are looking at gas gensets, for example, there's still also diesels involved there, because the ability of a gas engine to run up quickly and be able to support a large load is not as good as a diesel engine, similar to your car. Diesel is able to start and provides torque, and a petrol engine is not quite as good. And it's very similar in terms of the science with the gensets. On the fuel cells, I think, again, fuel cells, slightly different technology, but there are warm-up times on fuel cells. There's a lot of work going on in terms of how do you bring fuel cells up to speed quickly. And I think, you know, fuel cells, you know, probably is part of a solution. I think, you know, as we go forward, there will be a combination of technologies, because the ability to start fuel cells probably requires other technologies to give you that initial picking up of a load whilst you actually run things up to be able to deliver what you need as a load requirement. So I think, you know, the architecture of how backup power will be designed would change and would be adapted to allow for the differences in the technologies. So I think, you know, what we have today is a good solution in terms of what's required at the output level, but obviously we're striving to move towards something that environmentally is seen as being and has an impact that's less driven around the fossil fuel issues.
And obviously today you've outlined the walk-in enclosure, which is aimed at the sort of top end of the market. But you alluded to it in the presentation about edge, and I'm just wondering, I mean, is it as simple as just providing, you know, much smaller power supply, or bearing in mind the locations a lot of these edge facilities, is reliability sort of super critical? I'm not saying, you know, they aren't normally reliable, but you have to be sort of extra careful to make sure they're reliable. And you mentioned the noise issue. Potentially, if they're going to end up on every street corner to control, you know, autonomous vehicles, as we're sort of led to believe, you know, the noise, if you can imagine all these kiosks down the road all humming away. So are there some challenges, I guess what I'm saying is, with providing power at the edge?
I mean, inevitably, yeah. Nobody wants something humming away on their street corner, do they? So I mean, I think, you know, where we are today, we have a range of products which at the smaller end, we have products that are designed for those types of environments in terms of noise and reliability. I mean, our view with it is, you know, you have customers that are demanding, and, you know, any machine downtime is not acceptable, and being able to respond to that quickly and being able to deal with any faults that there might be quickly is something that's really important. So in terms of service levels and being able to actually have people on the ground, and the network we have globally of trained technicians and engineers, and being able to do that is critically important, and part of the consideration that our customers have when they select equipment, whether it be from us or any of our competitors, is around the ability to support the product in the field. In terms of, so I don't think in terms of the reliability, we really see, you know, we see all of the applications as critical, so we approach it in the same way. And some of the products that we are looking at for edge have been to some fairly critical environments and locations. One of the products we've got out in the Antarctic, the British Antarctic Survey, so it's been sort of tested and operated in some fairly extreme conditions, with, you know, arguably life safety is quite a sort of a key sort of reliability issue. So you know, I think, you know, in terms of the way we approach it that yes, it has to be reliable and provide that level of security. Again, I think, you know, as we go forward, and edge becomes sort of out to the next level, I think, you know, we've seen edge technology in what's sort of historically been sort of semi-industrial type applications. So, you know, where you might have had things like telephone exchanges and that sort of stuff in the past, you sort of see it at that level. I think if we get to the level where, like you say, we've got backups on street corners in boxes, then yeah, clearly a genset humming away is not what people want. So again, you know, some of those technologies that we're talking about at the sort of the larger sort of domestic stroke industrial scales of things like battery technologies and fuel cells start to become quite interesting for those sorts of applications. So, you know, in the short term, yes, we do have products that are capable of doing that, and they are super silent. Some of the work that we did on with our rental product, which again obviously is the types of environments that those products go into, whether it be events or sort of locations where people don't want to hear a humming genset. So the engineering that went into building very low noise, reliable units, we've sort of adapted and upgraded even from those products to actually build stuff that's quite good for the edge applications, because of the concept that was originally based around. It's allowed us to use those types of products as a base for building this type of thing.
And maybe just one other thing, potentially related to edge, but more generally, we haven't talked much about sort of intelligence. So I'm guessing once upon a time you just delivered a UPS, it sat there sort of on its own, and people had to go and physically examine it, maintain, etc. I'm presuming that along with the other UPS folks, you're building quite a lot of intelligence to the system. So remote monitoring, management, etc., is another way of making life more efficient for people with them. Yeah,
it is. It's an interesting one, because there's a lot of capability in terms of remote monitoring and remote interrogation. Interestingly, most data center companies don't want to connect here because they see that as being a breach of their security, I guess. So no matter what security you put around it, most of them leave these things unplugged. So they'll monitor locally, and you tend to find most big data center companies we will link our systems, and we have all the protocols to link to all the various different power management and BMS and power systems. So they'll monitor it locally. They'll see that there's an issue, and then they'll pick up the phone and say, we need somebody to come and look at it. They're very reluctant to allow you to leave a machine connected permanently to a network. There's very few of them that I've ever known that have been any different from that. It doesn't seem to make any difference which customer it is. They love the ability to do it. They don't actually want to plug it in.
Right. Can you see that changing? I mean, again, maybe, I don't know, for possibly sort of sustainability, environmental reasons, it being more efficient to allow you trusted partners to do that, or do you think they will still, security of their environment is sort of paramount?
I think I don't know, maybe it tells you something about their view of security in IT. I don't know, but having worked for a couple of manufacturers over the years, it's never been any different. It doesn't seem to make any difference. They see the benefit, but they just don't seem to want to do it. I think again, if you look at opportunities and something that is possible, that a collaboration with an end user customer, and you're probably looking at the bigger customers. So you've got customers like there are operators out there like Google, Amazon, Microsoft. They all have technology that they use with customers and interface with. We use it every day.
Opening web page.
Sorry, that was I mentioned a word then, and unfortunately somebody responded to it. There you go. They like to be permanently connected to us. But I think if they're part of the solution, then they want to be involved with it. But I think, as a third party, even as a trusted supplier, the ability to connect into a data center on what they see as a critical part of their infrastructure has always been something that's been sort of a holy grail that nobody's ever wanted to do it. They might. We tend to find that what happens is if there's a problem, then they'll make a connection to it so that you can interrogate it. But in terms of monitoring it and in terms of having visibility of it 24/7, it's never been something that they've been very keen on allowing access to. But certainly an opportunity.
I think that's covered most of the sort of extra bits I had, so that's good, thanks.